Okay, Carmen, I'm going to attempt to give you a physics lesson. Hopefully, I don't get the answer wrong this time. You asked me a roller coaster starts at rest at the top of a hill 15 meters above ground. How fast is the roller coaster going when it is 4 meters above ground? I drew a little illustration here showing you the roller coaster at the top of the hill at 15 meters up. That's point A. And then the roller coaster at point B, which is 4 meters above ground. So a couple things we want to figure out. One is, what is the height that we're dealing with? The net height obviously is 15 minus 4 or 11. And you can see how I've got that illustrated here. So we're really dealing with an elevation loss of 11 meters. Next thing you want to know is potential energy is always equal to kinetic energy. At the top of the hill, the roller coaster at rest has zero potential energy, but as it's released and it starts to go down the hill, it's gaining kinetic energy. I'm sorry, at the top of the hill, it has all potential energy and zero kinetic energy. As it goes down the hill, it's losing potential energy and gaining kinetic energy at the same rate. PE and KE are always equal to each other. That's the whole definition of conservation of energy. You never lose the energy. It just changes from one form to the next. Also in this problem, I should point out there's no friction mentioned. So we're going to assume that this is all, theoretical or inside a vacuum. There's no friction to worry about. So no loss of energy to friction, heat, that sort of thing. So PE and KE are equal to each other. Now, potential energy, if you want to know how to calculate potential energy, you need to know the mass of the object. You need to know the acceleration, which in this case, because we're dealing with planet Earth and gravity, that is g. And g is equal to 9.8 meters per second squared. So we know what g is in that. And we know what h is. Again, that's 11 meters. So we've got part of what we know there. We also know that kinetic energy is equal to 1/2 the mass times velocity squared. Well, we don't know what the velocity is. That's what we're trying to figure out. What we do know is that because PE equals KE, we can write this equation over here as mgh equals 1/2 m times velocity squared. We don't know the mass of the roller coaster. It's an unknown to us, but it doesn't matter because we know that it's equal on both sides of the equation. That means we can divide both sides by m and we can get rid of mass for all intents and purposes. So that leaves us with gh equals 1/2 velocity squared. Well, how do you get rid of this 1/2? You have to multiply it by its inverse, which is 2 over 1, or just 2. So if you do that, 2 over 1 over here cancels out, and then 2 over 1 over here comes down to 2 times g times h equals velocity squared. Now, we want to get rid of this square, so we take the square root of that side, which means we also have to take the square root of the other side, which gives us finally something we can work with here, which is v, which is velocity, that's what we're looking for, equals the square root of 2gh. Well, we know what g and h are, so we can plug those in right here, 9.8 and 11. If we multiply that out on our calculator, we get 215.6. So now we take the square root of 215.6, and that gives us a velocity of 14.68 meters per second. And I just did some quick math, and that kind of comes out to roughly 29 miles per hour. So that felt right to me as a gut check in terms of like how fast something might be going as a roller coaster rolling down the hill. So I think I got the answer correct this time. We shall see. If you enjoyed this, please hit like and subscribe.